Hi, this is section 8.5, the video for tonight. Angles, of elevation and depression. So we've used triangles to solve for, or trigonometry to solve for missing parts of triangles. Today is basically the application section of this, where we're going to use that trig in places where we use right triangles to find missing lengths and everything else. So the first thing we have to do is define what in the world angle of elevation is. So we've used similar triangles before, but now we're going to use specifically angles of elevation and depression and trig to find missing values. So an angle of elevation is an angle formed uh, by the horizontal, okay, a horizontal line, and the observer's line of sight to the object above the line. So for instance, right here, here's the angle of elevation. Right down here is the, this right here is the horizontal, okay. This line here is the line of sight, this diagonal line, so like this guy's looking at the person up in the stands, waving to him. And that angle formed between the horizontal and that line is the angle of elevation. Now the angle of depression, that is the angle formed by the horizontal line and an observer's line of sight that is below the horizontal line. So here's that horizontal line right here that they're talking about. So basically it'd be for this drawing, it'd be the person up in the stands. They're horizontal. And then the angle of depression is the angle formed between the line of sight and below that horizontal. So it's this line here, this angle, and now this line of sight again. And here's a big key part for this, because this is one of the things that people get confused about, is keeping it straight. Horizontal lines are parallel. So the angle of elevation, the angle of depression in the diagram are congruent by the alternate interior angles theorem. So basically, they're the same thing. It just depends upon your point of perspective. Are you the person up at the top or the person at the bottom in this case? If you're the person at the top, it's your angle of depression. If you're the person at the bottom, it's your angle of elevation, and they're both equal. So a lot of times in homework, what's going to happen is you're going to have to make a drawing of this and then draw on the triangle. Because right now, if we wanted to draw on the triangle, it would be, let's see here, this segment, and then this segment, and then this segment for the guy on top. And you'd have a little right angle here. Okay. And then you just would flip that, and it would become that guy's right triangle and his right angle here. Okay. So we have two right triangles basically. And we'll use these to solve for missing angles and missing side lengths. So here's our first problem. Okay. The crossbar of a goal post is 10 feet high. If a field goal attempt is made 25 yards from the base of the goal post that clears the goal by a foot, what is the smallest angle of elevation at which the ball could have been kicked to the nearest degree? Okay, so like I said, the first tricky thing for this is the drawing. So we have a guy kicking a field goal. So here's the ground. Here's the goalpost. And he is, right here, 25 yards away. Okay, that's what we have. It's 25 yards away. Now, the goalpost is 10 feet high. Okay, and when he kicks it, let's make that in red. When he kicks it, it clears the goalpost by 1 foot. Okay. Now, obviously, this, if you've ever watched football, know this isn't how you do it. You don't just kick it a straight line. There's normally some kind of arc to it. But we're looking for minimal. So, like, we'd have to kick it like a laser beam from the ground right up to there. Okay. Now, what we're looking for then is, what is this angle right here? What's an angle measure? And that's the minimum, because again, he could have kicked it up higher, it could have floated a bit, maybe just kind of come down. But if it were a straight laser beam, that's the smallest angle we could hit it at. So what we have to realize is we really have a right triangle in this drawing. The tricky part about this one, other than the trig itself and the drawing, is, this is yards, these guys are feet. So I'm actually kicking it 11 feet in the air because it's 10 foot plus 1 foot. Okay. but this is 25 yards. In order for me to work with this, I really need to have them in the same units. The easiest thing to do is to multiply this by 3 because there are 3 feet in a yard and say, oh yeah, this is 75 feet. If you try to convert this to yards, 11 is not divisible by 3. It doesn't work out. So we're looking at a triangle that's 11 foot, 75 foot. And this is the angle we're looking for, which a lot of times the book calls theta, if I haven't mentioned that in class or not. Circle with a line through it. That's the Greek letter theta. Okay. So now we go back and say, okay, I'm looking for this angle. And we go back to our trig. Well, what is the 11? The 11 is the opposite. What is the 75? 75 is the adjacent. And so now the question is going to pop up on the screen for you as to which trig function I would use to solve for theta. Would I use sine, cosine, or tangent? Okay, so here we are now. This is opposite, this is adjacent. That means we're going to use either sine, cosine, or tangent. Sorry, TOA. And we have opposite and adjacent. Hopefully you said tangent. So for this problem then, the tangent of theta is 11 over 75. Now, in order to figure out then what theta has to be, that's where that inverse function from the day before comes into play. So we'll do inverse tangent of 11 over 75, because that tells us then what the angle is that gives us that tangent. So turn your calculators on. Make sure your mode is in degree. So if you use this, if you're using a scientific, it normally starts there. If you're using a graphing, it's normally what we call radian mode. So make sure you're in degree mode. And then we'll do second tangent 11 divided by 75. And we get 8.343. So it had to be at least 8 point to the nearest degree, so at least 8 degrees. That's how high we had to kick that. Okay, so that was the first example. Now on to the second example. Okay, so a lifeguard is watching from a beach, okay, a line of sight 6 feet above the ground. She sees a swimmer at an angle of depression of 8 degrees. How far away from the tower is the swimmer? Okay, so I don't need the calculator, so I'm going to put him away for a minute. So we're looking here at, again, a lifeguard watching a beach from line of sight 6 feet above the ground. So the thing is in this drawing, and this didn't copy out very well, but you have the one in your notes or your book. She's 6 feet above the ground, which means then too, this is 6 feet above the ground. Okay, so how far away is the tower from the swimmer? Not how far away is she, but how far away is the tower? So what they want to know is this distance right here. Well, that's this distance. Okay, that's x. So when we look at this as far as our triangle goes, I'll trace the triangle in red to make it stand out a little bit better in the video. She's got her line of sight that she's staring at the swimmer. She's got the horizontal. This is actually an angle of depression of 8 degrees, but here's our right triangle. And so when I take that out of the context of the drawing, this is what we want to know. What is x if this is 8 degrees here and this is 6 feet here? What is x feet here? So real quick, I'm going to have it pop up real quick, ask you a quick question. What would we use to solve for x? We'd use sine, cosine, or tangent. And then, yeah, you'll answer for me. Okay, so hopefully you said, well, let's look. 6 is the opposite. X is the adjacent, and again, going back to SOHCAHTOA, that's tangent. Opposite over adjacent. Now, this time's a little different though, because I'm not solving for an angle like I did before. I'm going to just solve straight up for a side. So I get to just set up my proportion. Tangent of 8 degrees equals opposite over adjacent, which is 6 over x. Now this is the more I guess, not too complicated, but it's the more complicated of the solving of any of them, whenever the variable's in the denominator. So what you have to do is you have to multiply both sides by x first to cancel it off. Okay. And then you get x times the tangent of 8 equals 6, and then divide by the tangent of 8. Normally by this point, some of you guys just have caught that oh, if this is in the bottom, I'm just going to divide by the tangent of 8, and that's fine. I mean, I'm just walking through the algebra, but it is going to be 6 divided by the tangent of 8, which then we get our calculator out. 6 divided by tangent 8. And we get 42.7 feet. If we go to the nearest tenth. Okay. So yeah, we'll look at more problems in class, but that's the basic idea for this section.